In this next problem, we introduce a term called activity. Now, we had this term earlier in the class, but now it has a different meaning. Now it means basically the radioactivity of something. And an activity is given in the unit of a curie. A curie is defined as 3.7 times 10 to the 10th decays per second. So it's essentially this many alpha particles that are released every second. And when a substance releases that many alpha particles in 1 second, then it's said to have an activity of 1 curie. Now, from homework 6, problem number 8, it asks what mass of sodium sulfate, and now the sulfate is radioactive, that sulfur is 38, it's normally 32. This one's radioactive, so it's going to decay by giving off either alpha or beta particles. And it says what mass of sodium sulfate has an activity of 10.0 millicurie, and it gives the half-life of that is 1.033 times 10 to the 4th seconds. Okay, so we want to find the N essentially, because that's going to give us the mass of this substance that is decaying. Rate equals Kn. The rate equals 10 millicuries. That was given to us. And when something has an activity of 10 millicuries, that means that's its decay rate. And so how many decays is that per second? That is 3.7 times 10 to the 10th. That is 3.7 times 10 to the 8th decays per second. 10 millicuries, 3.7 times 10 to the 8th decays per second. And that equals K times N. Now K is always 0.693 times the half, or divided by the half-life. And the half-life was given to us. We may have to convert it into seconds, but in seconds, 1.033 times 10 to the 4th. And so K can be calculated as 0.693 divided by the half-life, and that gives us 6.707 times 10 to the minus 5th per second. That is the rate constant. Now we can find the NT value, which is the number of S38 atoms, and that equals rate over K, and we get 5.5 times 10 to the 12th S38 atoms. But now here we have to do stoichiometry and convert this into the mass of sodium sulfate. So this many atoms converted to moles times the mole ratio of sulfur in that compound, which is 1 to 1, gives us the moles, 9.16 times 10 to the minus 12 of sodium 38 sulfate. And then we have to convert that to grams. The mass of 38 sulfur is 38. So 2 times 23 plus 38 plus 4 times 16 gives 148. You have the number of moles of that compound times its molar mass, gives you the number of grams of that compound, and then they want the answer in nanograms. So you multiply it times 10 to the 9th nanograms over gram to get 1.3 nanograms.